Hello everyone, welcome to my videos. So in this video, we will continue our topics in statistics. So in last video, we already talked about what is a central limiting theorem. And in this videos, we will use this theorem to talk about if we have two random samples, and then what can we do for the difference of the means of these two random variables. So if you don't know what is a random sample, please review my last videos to look at the definition. So now if we have two different populations and then we randomly select the samples, so that means we will get two random samples from these two populations. So if for the first population, we assume the mean of this population is mu1, and the second with the variance sigma 1 square. And for the second population, they have the mean mu2 and with another variance sigma 2 square. Then what we want to do is we want to select two random samples from these two populations independently. So what this means? This means you can assume that if we want to look at, for example, a score of a two group of students, for example, from class 1 and class 2, and then when we select the students, we randomly select. So that means from the first class, assume they have a lot of students, right? We randomly select like 10 students. And then we select maybe 20 students from the second class. And if here we say independence, it means the student I select in the first one won't infect the student I select from the second class. So if you say like, okay, if we just rank the students and then we say select, okay, we select the first 10 from both of the class, no matter is ordered the student by their maybe ID number or by their any about registration orders, this not means independence. So here the independent means the select is totally no effect on each other. So when we have this independence, and then for each of this random sample, we can compute their sample mean, right? So it will denoted by x bar 1 and x bar 2. So then, of course, because the original random sample are independent with each other, then of course this x bar 1 and x bar 2 should also independence with each other. So now our question is, what is the difference between this sample mean? Do they follow some distribution? Can we have any conclusion about them? So here we can use the central limiting theorem to help us. So because the central limiting theorem tells us no matter what the original distribution of our random sample, we know that this sample mean follows a normal distribution with a mean as mu and variance as sigma squared over n when the sample size is really large. So here for this question, when we talk about two sample means, it's still same. So that means here by the central limiting theorem, we have when n1 is large enough, we know this x1 bar will follow a normal distribution when the mu1 as the mean and sigma 1 squared over n1 as the variance. And then similarly, when we have this n2 is also large enough, so then what we will have the second sample mean. It also follows a normal distribution with the random with the mean and variance. Everything is for the subtitle 2. Okay, so now we know these two sample means all follows a normal distribution. Then we will use our knowledge of the linear functions of random variables. At that part, we said if we have linear functions of a random variable follows a normal distribution, Then after this linear function, so here our linear function is x1 bar minus x2 bar. Then this will still follows a normal distribution with another mean and variance. So here this mean will follows as the new mean is mu1 minus mu2, and the new variance is sigma 1 square over n1 plus sigma 2 square over n2. Okay, so this actually is from our knowledge of linear functions of random variables. So if you don't know this, please look at my video about that topic. So now when we summarize about this, with the knowledge of how to rewrite a normal random variable to a standard normal random variable, we can have our property or kind of like the formula here. So this is by rewrite this equation as a notation n, we know as a notation capital Z, we know this one is follows a standard normal random variable. So here, of course, by our central limited theorem, here we need to require our n1 and n2 large enough. So this we can have this conclusion. So here, as what I taught in last video about central limited theorem, so this n1 and n2 is large enough. It's basic. Depends on your requirement of the current. However, in our videos and also in general in the project of the engineering, here we say the large enough is means n1 and n2 is greater than 30. So here if we have the n1 and n2 is greater than 30 at the same time, then we will have this conclusion. Okay, so now you know if we have two classes of students and we want to randomly select two random sample from them, then that means our n1 and n2 need to be more than 30. So in other words, in each of the class, you should at least have more than 30 students to make you use this approximation, or in other words, this central limited theorem. And then if all the class students is more than 30 and your sample is also more than 30, then you can assume the difference between this two sample mean follows this normal distribution. Okay, so by this theorem, actually we can have a lot of applications of this theorem. So for example, if you talk about one of the products created by two maybe equipment, and then you want to know if these two equipment produce similar products. For example, if they produce some hammer, will this two hammer is strong same? Or like if you use two equipments to produce some steel, you want to know the flexibility of this steel are same of each or not. So now you know what you can do is you use each of these equipments to produce more than 30 products, and then you randomly select more than 30 items from these products, and then you can compute their sample mean, and then to try to find do they have the difference, or in what probabilities their difference is larger than a specific number. Okay, so this is some applications in the manufacturing, and you can have much more applications of this difference of two sample means. So if you're interested in the topics, please leave a comment, and I will later upload maybe some videos about the application of this. Okay, so thank you for your attention in these videos. Please subscribe my channel. And in next videos, I will start to talk about other topics in our statistics about the parameter estimations. So see you in next video.